The drop. The drop.
Now let's move on to the most important part of our project, the compost. Each of the composts plays a key role in the working of our two-rotor drone. Let's go through them one by one. First, we used a lithium polymer battery. This is a 4S pack with a voltage 14.8 volts and capacity of 3300 megahertz. It provides the required power for the motors, servos, and the flight controller, and is lightweight compared to other types of batteries, making it ideal for drones. The next compound is the BRDC motor, which is responsible for generating the thrust. Brushless motors are efficient, powerful, and durable, which make them the standard choice for drones. Next, we use the servo motor. Its job is to control the mechanism of the drone. By adjusting the angles, the servo helps in stabilization. They use the model series MG series and the maximum rotation is 180 degree. Here you can see the three blade propeller made of polycarbonate. It has a length of about 130 millimeters and a pitch of 4.9 inches. The propeller converts the motor's rotation into thrust, allowing the drone to lift and move. Our flight control is the KK 2.1.5. It uses the Atmega 644 microcontroller and operates at an input voltage between 4.8 and 6 volts. The controller continuously processes signals from the receiver and sensors to keep the drone balanced and stable during the flight. Next, we see the 3D printing machine. The frame of our drone was made using a solid base 3D printing machine. This 3D printing allows you to create a lightweight, durable frame with a customized design, which would be difficult with the traditional manufacturing. As the 3D printing material, we used the PLA filament with a diameter of 1.75 mm. PLA is biodegradable, easily to print, and provides enough strength for lightweight drone structures. For remote control, we use the FS ISIS X transmitter and receiver system. It works on the 2.4 GHz frequency range and with the 6 channels, allowing real-time communication between the pilot and the drone. Next, we see the electronic speed controller or ESC. Ours is rated at 30 amps and weighs about 23 grams. It regulates the power supply from the battery to the BLDC motor, ensuring smooth and precise control of motor speed. Finally, we see the propeller guard to using the 3D printing. This is a lightweight safety accessory made of polycarbonate that prevents the propellers from hitting obstacles and also protects the user during operation. So these are the key compounds that together we make up a two-rotor drone. Each part plays a vital role in ensuring stability, performance, and safety.
இது சும்மா ட்ரைலர் தாம்மா, மெயின் பிக்சர் நீ இன்னும் பார்க்கல.
It's the rise of the dragon.